everybody. So we're going to go over a quick presentation about how we at JLL go and use the IoT and other types of digitalization tools in order to advance the reliability and asset management. So for those of you in the back that don't know what I look like, there you go. So my name is Brendon Russ. I am the lead in the Americas for reliability and asset management for Jones Lang LaSalle. I have 15 years of experience in industrial manufacturing across mainly food manufacturing, but also pharmaceuticals and foundries. And as part of JLL, I think with the next one will probably go. So JLL is a corporate real estate conglomerate with parts of the business are dedicated towards asset management. So as a service to various clients, we try to leverage all of the different arms of real estate, corporate real estate and real estate holdings as part of assets and how you maintain them. And we have a tagline of asset management for a better world. So for a better world of work. Throughout our global platform, as you can see on the screen, we're kind of all over the place. I'm over the Americas, and this is actually an old slide. It's only about 2 months old, and all these numbers have now increased, at least 2 or 3 in each region. So we have a dedicated platform to send out to help our clients and our partners with their asset management of their facilities, be it office space or manufacturing. It really doesn't matter, whatever the asset the clients need. And then here's just a quick list of some of those partners that we utilize. So it's important to understand is that we're not necessarily a service. Those assets are ours. When we show up at a facility, at a site, the clients don't care. Those are our assets to maintain. And this is where I kind of get into kind of some of the things that we encounter on a daily basis. So when we typically come to a site, we're typically taking care of facilities management, right? And facilities is usually, there's a cultural issue with facilities versus any type of manufacturing assets, right? We deal with the same types of assets as everything else in manufacturing: pumps, fans, compressors, boilers, HVAC, but you name it, it's pretty much the same stuff as if it were making widgets. It's just taking care of a facility or a campus, or sometimes it is actually part of the critical environment that's supporting the actual manufacturing process. But because it's considered facilities, it's not given the same level of care. So what you typically see is there'll be little to no infrastructure built towards the monitoring or taking care of those assets. They're not usually included in any type of asset management plan, strategic asset management, because it's not directly associated to what the company views as valuable. Therefore, when we show up, you may or may not find some proprietary systems on a couple of little items or nothing at all, right? So when you look at this, you'll see some packaged boilers there with local HMI screens that you can't really do anything with. It only exists there and nowhere else. Or you might find pump sets for as long as the eye can see that are all redundant with absolutely nothing, run to fail because you have several of them, right? Or HVAC equipment, exhaust fans that are under regulated requirements because they're for evacuating a building in case of some sort of release, but they just sit there. They only get run maybe every 6 months. But we have to find a way to become a little more proactive and to kind of shake up the idea that these actually assist in your facilities, right? This actually helps you make yourself busy. Now, in my 15 years of industrial manufacturing, I can tell you with certainty, it did not matter what was going on in the plant. If the CEO's office was hot or cold, that became the most important thing that day. All right. So when we talk about facilities, just understand that it's usually not on your mind, but it does come up when something goes wrong because it's not on your view. So how do we try to find a way to get more proactive in some of these assets that are not necessarily captured? So at JLL, this is the type of approach that we typically take. So the typical things that we find are you might have a CMMS, you might not. You might have a spreadsheet that tells you, okay, every week go out and do this, or every year just go turn it on, make sure it runs, right? It's typically, there's no thought behind it, usually OEM prescripted maintenance. So what we try to do is like, all right, so leveraging technology that is becoming more and more available and more adaptable. How can we use technology? And we have several things that we'll go over that we utilize within JLL for our assets to, number one, actually get some monitoring on the equipment. try to do some analytics with that data, or try to utilize what other type of operational data that might be around. And then how do we get some insights towards creating kind of a life cycle asset management approach towards these assets? And of course, you always see what we always try to get to when we talk about reliability and asset management: lower cost of ownership, TCO, try to get more prescriptive, really build out the concept of life cycle, put it as part of your asset management strategy, really typical stuff. All right. And this is our philosophy when it comes to maintenance strategies. So obviously we like to start at the baseline of compliance. We want to keep people out of jail, even though these might be considered facility asset management. Sometimes the environmental life safety factors are critical, and we try to make that as a base. And then everything up this triangle is a function of essentially strategy and criticality, right? Asset criticality. So one part of this is usually trying to break the cycle within an organization that, these assets need to be taken seriously. They're not just an exhaust fan, right? It's critical to your environment in a way, or else it wouldn't be there by design. So we look at, the typical PM strategy, preventive maintenance, then looking up about that, what kind of condition monitoring, when appropriate, based on the strategy, would you apply? And then even further on those more critical assets, what can we utilize in terms of IoT technologies to actually further that along to become more prescriptive, right? Become more proactive. We have a strategic partnership with Reliability Web as part of the Reliability Leadership Institute. And we leverage the utilization of the uptime elements pretty hard in our approach, right? So for those of you that don't know, the uptime elements is kind of a standard in reliability and asset management, and they have a framework which provides a pretty easy guide for common language and common understanding of some of the typical components of reliability and asset management. But when it comes to things like the Internet of Things or digitalization or digital transformation, they have a completely knowledge domain based on that. So if you look at that purple box on the right-hand side, you'll see there's 5 elements on the top and 3 elements on the bottom. So those 5 elements on the top, source, connect, collect, analyze, and do, that represents the transformation of raw data collected from somewhere into actionable information, right? So figure out how you're going to get your information, that's source, how that information is going to be collected, that's collect, where is it going to be maintained, that's connect, how is it going to be washed, how's that data going to be filtered, and then essentially what you're going to do with it, right? Because you always want to know what you're going to do before you go slap sensors on things. And those 3 at the bottom are probably the underlying foundational concepts towards the Internet of Things according to Uptime Elements. So you have data governance, who's going to own the data, what is the data going to be look like, how are you going to manage it, is there going to be a steering committee that kind of overlooks everything. Then you have trustworthiness, so cybersecurity and training to make sure that we're not going to have a loose problem where somebody keying in the wrong information takes down your system. And then digital twin was essentially, besides the overall concept of digital twin, how are you going to interact with your data, right? Is it just going to be a full-blown, immersive 3D digital twin, or is it just going to be an enhanced HMI? That kind of concept. And as a part of that, we also like to bring attention to the concept that everybody knows or has seen a PF curve, right? But we like to go back even further than just when you're already there. We like to look in terms of a full life cycle asset management. And the rule of 10 is pretty simple. It takes less than a penny to rethink your process. It takes about a dime to fix it in design, all the way to thousands of dollars once it's already installed and operational. So we try to get in as early as we can within the actual life cycle of an asset to make sure that whatever asset that gets put in has the best case for extending its life for as long as possible, while trying to utilize, based on criticality, different types of technologies to identify potential failure modes and correct them before they actually cause any disruption to the system. So here's an example of where we're going with this. So in a particular site, we installed a monitoring system that we call IntelliCommand, that I'll go into a little bit of information in a minute. And we installed vibration sensors on top of that. And this is on air handling units. Now, this particular site had dozens and dozens of air handling units. Gigantic fan, huge fan, coils, dampeners, etc. That red line is the system's understanding of what would be required from the fan, the VFD capacity, 0 to 100%. How hard would that fan need to work? The gray is the actual output of that fan. So when we turned it on, I think, does this work? Yeah. That's what we got immediately, right? And then just using the vibration information, looking at this and looking at the screen, you would say, all right, well, we're in line with what the system thinks it should be going through versus what we actually had. So our system is actually looking at the real world operational demand of the system and assumes, with all of the criteria in it, this is what I think the fan should be doing. And if the gray matches the red, everybody thinks we're good and happy. When we're looking at the vibration data, we found, okay, there's some issues here. We found misalignment, belt slippage, tensioning issues. So after we did the basics of, just condition monitoring, you get to the yellow. Everything dropped down, right? We thought we were doing great. And then our IntelliCommand was starting to integrate and machine learn what was going on in the system around it. We were only focused on what that actual asset was doing and not, what the system was doing. And the system began to notice and identify issues around the actual piece of equipment that was affecting that equipment's performance. And in this particular case here on the screen, there's a device known as a VAV, a variable airflow volume unit. It's essentially a fancy dampener. So I want you to imagine that this air unit is just like pumping air through a distribution system, and at every point of use, there's one of these little dampener units opening and closing as required to maintain the system. And there's a few of these VAVs that were indicating on the screen their position. However, in reality, that was not the case. And we can actually start to see that the airflow was not matching what the percentage was supposed to be on the VAV. So we went out there and said, and lo and behold, there was about 5 or 6 of these that need to be recalibrated. And after we do that, we can get to this, what you get on the right-hand side. Suddenly, what the system thought we needed versus what we actually did. And this is where it gets into, a lot of what we heard over the last couple of days about sustainability. This got the attention of every sustainable person that was within that 50-mile range of that unit. Because when we talk about reliability and asset management, we said we need to fix this so we don't have to replace the motor. We need to lubricate properly so we don't have to replace the bearing. These are cost avoidance measures, right? That was real world, live, instant energy savings to the tune of millions per year when it was actually taken and applied across all of those air handling units on that system. So it very quickly became, oh, thank you. Sorry about that. It very quickly became easier to install more and more of these types of systems on our equipment based on a sustainability approach rather than just pure reliability and asset management. And then this is just types of things that we kind of see as we go along: tensioning, filter issues, drivetrain issues, really the kind of standard stuff you get with condition monitoring. So IntelliCommand is ostensibly a hybrid between a standard operational HMI and an analytical platform. You spot what the equipment is, what the design of the system is, and the understanding of the system, and then it just watches it. And it watches it over time. You give it a baseline, establish a baseline, and then it watches your system, and after a certain amount of time, it will start to identify leading indicators that are affecting the actual equipment and the system performance itself. So what we've done is take that and applied that connection to our CMMS of choice, which is Corrigo, which is actually always on-demand mobile on our technician cell phones and our facility manager cell phones. So we can be able to identify which of those types of actions would be required to go immediately get some help in Corrigo, immediately establish work order history, and notify our technicians of potential issues. Now, one thing I want to make sure is clear is that the human element can never be understated. With all the technology that we throw here, doing this without people is impossible. So if we try to do something without telling people, or we think we're introducing new systems, this will crash pretty hard, pretty fast. And from that, we're actually able to pull an inordinate amount of information that we could look at our asset data quality, compliance, work order utilization. But more importantly, when I keep talking about lifecycle asset management, being able to use the condition data that we're pulling off of our assets to tell us where we believe it is in our life cycle. Now, we use different standards such as BOMA and SIPC, which are facility maintenance and building standards organizations for determining life cycles of typical types of assets. We can actually pull up and see, okay, where's our forecast for a potential replacement cycle of all of our assets within the given year, which gives us a good starting point for capital replacements, which is extremely helpful when we try to understand, when we go into a new site and not understanding the full realization of our asset list. This gives us a good step. So some of the lessons learned of doing these types of systems over and over is we need to make sure we have a clear understanding of what it is you want to get out of your systems. We were looking for life cycle asset management, being able to operationally help with our systems. You need to understand what the data is and how you're going to validate that data. So I said it before, but you don't want to just slap some sensors on some things just because you can. You need to make sure that anything you put out there has a purpose. I can't imagine I'm the only one that's gone and looked at an HMI and seen 5 or 6 red blinking lights that nobody's paying attention to because it doesn't mean anything to them. Establish your data governance, who owns the data, who's responsible. Ensure that that actually is important, tied to the business need. Communicate how the system will be operated. Make sure of the data itself. Don't needlessly gather data again. Interoperability is a huge thing because if you're dealing with a lot of different independent systems, you may have to get creative with some of your messaging. You know, that can either just be PLC messaging, or you might have to get it through CSV file transfers or whatever you need to do to actually translate your data. And focus on the specific need to know, not anything that makes a pretty graph. I just need information. All right, thank you.